everyone, and welcome to Strand Explains. My name is Sakshi Shingle, and I'm joined by RK Betadapura. Sorry. How do I pronounce your last name?
It's okay. You don't have to pronounce it. It's better the Pura, but you don't
Okay.
have to say it. Yeah.
Okay, how
I
about it?
am just RK. That's why it's easy. Yeah.
Okay, great. I'm Sakshi, and I'm joined by RK today. Thanks, RK, so much for joining us. How are you doing?
I am doing fantastic. And I am completely okay with my name being mispronounced. It happens everywhere. So
Fair enough. I can definitely relate to that. Um, so today we thought we'd talk about COVID, just a little explanation on what it is and a briefer on the vaccines that are in the news, given that there's so much excitement around them, just trying to understand what exactly they are, what is happening. So any initial thoughts, RK, about it? Like, how's it affected your work? I know we've spoken a little bit about how it's affected our lives at home, but how has it affected your work habits, holidaying, and such?
it's been up and down a lot.
Mhm.
I really like the fact that we're working from home because I'm used to that. But on
Yeah.
the other hand, we are kind of working from home, and sometimes it's hard to have a separation between your workspace and, my exercise area is right there, and then my guitars are over there, and then this is my workplace. So yeah, you have to define your boundaries much more concisely in this time. So that's really the only way it's affected me. But I'm probably one of the more fortunate ones.
Definitely. I mean, it's the same over here. My piano's right over there. And so it's weird having, and there's a bed, which is not my bed, but it's very difficult at like 3 o'clock in the afternoon not to go take a nap because it's right there. So I definitely understand, creating those boundaries. But again, like you said, we're one of some of the more fortunate people. So let's maybe just jump right into it, if that's cool. So I thought I'd start by just introducing what coronaviruses are, what their structure is, etc. So as you can hopefully see on the screen over here, we have coronavirus. This is what it looks like. The internal genetic material is made of RNA, and that's what codes for the virus. And it's surrounded by a membrane which contains multiple proteins, including the spike or S protein. Now, the spike S or S protein is really important because it's what the virus uses to actually attach to the host cells. In this case, it'll be human cells to inject its genetic material. So, some quick virology 101 for all of you out there. The way viruses replicate is they'll attach to host cells, inject their own genetic material into the host cell, and from there, they will. From once they've injected their genetic material into the host cell, they will use its machinery, DNA replicating machinery, to create more copies of itself. And so over here, the coronavirus itself uses the spike protein to attach onto the host cell to help do that and to and start that process off. Yeah, so okay, with all of that information, could you maybe just talk about the two main platforms that exist, and we can get into how they work?
Yeah, absolutely. So there's the RNA platform that you see here with a total of six, candidates in clinical trials, and this includes the ones that you've heard of most recently, that are the Pfizer BioNTech vaccine and the Moderna vaccine. They both belong to this platform. And then there's the non-replicating viral vector platform, which is the second from the left here. And that has 9 candidates in clinical trials, including the one you've heard of from AstraZeneca and Oxford University. That's also interesting to folks in India who may be listening, because that's the one that the Serum Institute has signed up for to produce 100 million doses early next year.
Mhm.
Of course, there's the protein subunit platform, which has more in clinical trials, but we haven't heard from any of those yet. So we will only talk about the non-replicating adenovirus vector platform and the RNA platform today.
That sounds great. So I thought we could maybe start with the RNA platform. If nothing else, we have seen people starting to We have seen that people are starting to get that vaccine, both in the UK, and I think as of yesterday, today being the 14th of December, there were, sorry, the 15th of December, people in the US were actually injected with the Pfizer and BioNTech. So, there's everything is happening right now as we're explaining it, which is
Yeah.
exciting for sure. So, Aki, could you maybe
Yeah.
start off by explaining how the mRNA vaccine platform works?
Yeah, absolutely. And people, possibly people in the first line of defense against coronavirus, healthcare professionals are receiving the vaccine as we speak, and rightly so. And so, yeah, the one that's on everyone's minds right now is are the Pfizer and Moderna vaccines, and they're both based on the RNA platform. And you see the picture here. It starts with this notion that you have to inject part of the virus into the host. In this case, what it is that you're injecting into the host is part of the RNA that codes for the spike protein, the viral spike protein that you saw earlier,
Mhm.
right? And when you put that into the host cell immediately makes a protein out of it using the ribosome. And once that host cell dies, bits of that spike protein uh, are exuded into extracellular space, and they are detected as foreign antigens by the immune machinery of the host.
Mhm.
And once that happens, there's a long cascade of events
Mhm.
that eventually leads to the production of antibodies.
I
And
see.
those antibodies protect against eventual infection in exactly the way that you mentioned earlier, Sakshi, is you're priming the host uh, by producing these antibodies so that when the host actually comes across that infection in the wild,
Mhm.
it is ready to battle.
I see. And so what you're saying is that once this mRNA is injected and converted into those peptides, like you're saying, priming, the body knows in the future how to deal with COVID if it is to come across it in the wild. And so, is that how the AZ or Oxford vaccine work as well?
Yeah, it is more or less the same idea. What you're
Mhm.
injecting is slightly different.
I see.
So on the AZ Ox in the AZ Oxford vaccine, I should say, which is
Mhm.
based on the non-replicating viral vector platform, what you're injecting is not the mRNA of the spike protein. You're injecting uh, a harmless virus. Uh, in this case, it's an adenovirus that's been deactivated. And it's not just any adenovirus, it's an adenovirus that contains on its surface the spike corresponding to the coronavirus spike. Right? So
Mhm.
it's an adenovirus with a coronavirus spike, and you're injecting this into the host. Right? Now, the virus itself, the body of the adenovirus is harmless because it's been deactivated. So there's no infection caused to the human beings on account of the virus.
Mhm.
However, the spike protein, which is part of this chimeric virus that you created, is also now inside the human body. And so when, whatever cell it is that this virus is part of, when that cell dies, once again, bits of the spike protein make their way into intercellular space. They're detected as foreign antigens by the immune machinery of the host, and the immune machinery then generates a very similar response, creating these antibodies, and those antibodies protect against eventual infection.
I see. That makes sense. So, from what you're saying and what I'm understanding, we have these two different ways of getting some small amount of the coronavirus, which is non infectious, but is immunogenic, meaning that it won't harm you, but it will cause an immune response. And you're sort of trying to get that small piece into the body, in this case, that spike protein or a part of that spike protein, so that the body can trigger an immune response, and that immune response can lead to antibodies that are specific against the SARS-CoV-2. The human immune system is quite remarkable. And one of the things it can do is create these antibodies that are so specific to that are pretty specific, sorry, to these to different microbes like SARS-CoV-2, so that when it encounters it in the wild, it doesn't need to take that lag time of trying to figure out how to make the antibodies, and it has those antibodies ready to go so that it can trigger an immune response virtually immediately. Would that be accurate, RK?
Yes, yes,
Mhm.
that's exactly right. So
Mhm.
what the host is primed, and
Mhm.
once the host is primed, they can respond much more quickly than if it was just something that they encountered in the wild that they haven't seen before.
Thanks so much for that explanation, RK. So I think we'll stop there today. There's a never ending amount of material you can talk about when it comes to COVID and what's currently happening. We can talk, and we have more episodes lined up where we talk about the efficacy, we talk about the differences between these platforms, what the storage temperatures are, how long can they last, what do these things really mean for distribution. We'll talk about some common misconceptions that are out there. How is it safe for everyone to take it? What if they have comorbidities? What if they're slightly older? There's been talk about it causing infertility, which, spoiler alert, it doesn't. But we will try and get into the science and try and explain how these things work and why there isn't too much reason to be concerned. But on that note, sorry, I think we'll say bye. Any final thoughts or any closing thoughts, RK?
No, I'm just excited to begin these episodes, this series of episodes. It's very promising,
Me
and
too.
we
And I
hope,
mean, I've learned
yeah.
so much already in the last few weeks, and I can't wait to share that with everyone out there. So thanks so much. Have a great evening. Bye, RK.
Bye, Sakshi.